Hello and welcome to Physics Basket. We are on to the next topic wherein we will continue with the vector problems 3, and let's get started with a new set of problems. So this is the next question that says that there are three forces acting on a body such that the forces are F1, which is 3I plus 4J plus K, F2 is 2I minus 3J plus K, and F3 is I plus J, I minus J plus 5K. Then we are asked to find the unit vector in the direction of resultant vectors. Okay. So first thing is we need to find what is resultant vector, right? So let the resultant be F. So the F vector, we can say it as F equal to F1 plus F2 plus F3. Okay, so let's add this. So in this system, we can directly add basically I with I, J with J, and K with K, and that gives us the resultant vector in terms of I, J, and K. So it will be 3I plus 4J plus K plus F2 is this one, which is 2I minus 3J plus 2K. Okay. And then we have F3, which is I minus J plus 5K. Okay. And then with this, we are able to find the resultant. So let's add I with I. So 3I plus 2I, 5I plus, so this is 6I. 4, 4 plus 4 minus 3 is 1J minus J, it is 0J. Okay. And then we have K plus 5K, it is 6K plus 2K, sorry. So K plus 5K plus 5K, it is 8K. Nothing but it is 6I plus 8K. So this is our resultant vector. What we are asked to find is the unit vector in the direction of the vector. How do we represent a vector? Basically, the vector is always inclusive of its magnitude into the direction. So unit vector, we can say, so let F, we can say it is F cap. So F cap is the unit vector. So we are asked to find the F cap only, which is the unit vector in the direction of F. So we will say F cap is F vector by the magnitude of F itself, right? So let us write what is F. F, we already found this one, 6I plus 8K. And what is the magnitude? Since this is the vector we already found, so magnitude will be 6 square plus 8 square. Okay, so I, K being all perpendicular vectors, so we can directly say 6 square plus I square and square root of this. So nothing but our unit vector is 6I cap plus 8K cap by 36 plus 64. So square root of this is 10. So we get 3 by 5 I cap plus 4 by 5 K cap. This is our unit vector. So, okay, so this is the question that is with us. It says that the position vector of an object A, which is on an inclined surface at a distance 1/3 of the length of the inclined plane. So, it shows that it is L by 3. So, basically, what it means is that it is this part is L, right? This is L. And again, here it is given that this is 3 meters. So, what are the other dimensions that is given is uh, the this part is 12 meter, this is 12 meter, and then the origin is given The angle is given as 53 meter, and this width of this particular wedge is around 6 meter. The object is exactly at L by 3, which means that this is L by 3 and this rest of the portion will be, if we try to draw, it is 2L by 3, right? And now how do we know the position vector? Basically, since we know the origin, so from origin, if I try to draw a line, then we are able to find the position vector basically. So if we are able to move from the origin towards this particular point, then along x, y, and z, then we are able to find the position vector. So, uh, so let me do it separately in a separate diagram. So it's something like, before that, first thing is this y is already given 3 meter, which means that in y direction, so you have to move in all three different directions. So in y, you have to move some direction, some distance. Then in x, you need to do move some distance, and in z, you move some distance. You reach a. That is what we need to find out. Correct. So, so y part we can take it first, because already y we know we need to move till the center of the wedge, okay, along the incline. So this part is 3 meter. So in y we are moving by 3 meter. Okay. Now just consider a triangle exactly in the center of this wedge, something like this. And from this, since y position, the y direction movement is already determined, we need to find out the rest of the movement, like how much you move in the x direction till here, and how much you move in the z direction till here. If we are able to find that, then we are able to find the rest of the movement across x and z direction, right? So let us draw that imaginary triangle, which is exactly in the cross section, center of the section of this particular wedge. So something like this. Okay. Now you are here actually. This is the original part. So you have started from O, and already in the y direction you have moved till 3. Okay, 3 meter. Now here, this also becomes 53 degree. This 53 degree, and here is your object. Now this is again L, because this is the cross section only. So this is going to be L only, right? And what we need to find out is how much you move in x direction and how much you move in y direction. Sorry, not it is not y, it is z, and this is x. And then we can find the respective coordinates. Now this is a triangle. In this triangle, we already know this is also 12. This is also going to be 12. So if this is 12, then what is, we can find out L with in this triangle. So we'll say 12 by L equal to sine 53 degree. Okay, and then this is sine 53 degree, so we can find L equal to 12 by sine 53 degree, and then we get it, how much, sine 53 is 4 by 5, so 12 by 4 by 5, and we get 15 meter. So this means that this part till here it is L by 3, nothing but 5 meter, and from here to here it is 10 meter. As simple as that. So now once we find out this, now we can consider this triangle. This triangle, let us call it as, say, this point is A, right? So this point is A, so let me call it as P and Q. This is the point A, right? This is the point A. So P, Q, and A. So I need to find, this is O dash, let me call it as O dash. This was origin, so let me call it as O dash. So this point will be like, since I have moved by Y, so this is 0, 3, and 0, correct? So already this is 0, 3, and 0. Now here, what is, if I find P, OP, I need to find what is OP. That is one question for me. And then next I need to find what is PA. PA. And then I'm done actually. So I know how much I need to move in the X direction and how much I need to move in the Y direction, right? So with this, I'm done. So in this particular triangle APQ, in triangle AP and Q, uh, we can find out the value of AP, right? AP is or PA. So PA is one thing when we need to find out. So PA is equal to what? PA is AQ into sine 53 degree, and AQ is nothing but 12 by 3, which we already know it is 10 meter. So it is 10 into sine 53 degree is 4 by 5, and we get 8 meter. Okay, so we get the value of PA equal to 8 meter. Very good. So we get 8 meter here. So this means that it moves in the z direction by 8 meter. Next is we need to find the value of OP. We need to find the OP. But in this triangle APQ again, we can find out the value of PQ, right? And PQ is equal to, we can simply say it is AQ cos 53 degree. And what is AQ? AQ is already known. This is 10. Cos 53 degree is 3 by 5. So this gives us 6 meter. So if we know this is 6 meter, this is 6 meter. What is OQ? OQ we didn't find it yet. I think yes, but OQ is very simple again. So the total is 15 meter. So OQ will be OQ in this triangle. So let us call it as this is O dash, right? So this is O dash. Let me call it as S. So in O dash S and Q. Okay. So O dash S and Q triangle, we have OQ. OQ is equal to nothing but this SQ is L into cos 53 degree, correct? OQ is SQ cos 53 degree or nothing but L cos 53 degree, and L is 15 already we know. So 15 into 53 degree is what? Cos 53 degree is 3 by 5. So we get 9. Okay. So the whole we get it as 9 meter, and PQ already we got it as 6 meter. So let me change the color. What color I should choose here? Okay. So now we have PQ is already known. This is also known. So this part is very simple. It is just 9 minus 6 is 3 meters. So OP is equal to 3 meter. Okay. So now we are aware of how much it moved on the Y direction. It is already, we know it is 3 meter, as simple as that. And then in X direction, this is X direction, and this is the Z direction. This is Z direction. So what is my position vector? Position vector for A, right? For A will be what it has moved in X direction, Ti plus, all are positive here, and what it has moved in Y direction, 3J, plus what it has moved in Z direction, 8K. So this is the position vector of A in this particular wedge, basically the object, right?